Afternoon, everybody. So my name is Bill Downing. I'm the president of Structulam Products out of Penticton. So I'd start off with this shot here. Here's me living the dream, fresh out of school as a forester in 1985 with my dog and my Ford. Here I am a couple weeks ago also with my dog and my Ford. So you can see how far I've come in the last 30 years. And haven't aged a bit either, by the way. So I started off my career as a forester, and currently I'm the president of this company, which is a pretty cool company in Penticton. Called Structulam Products. So it started in 1962 as a fabricator of glue laminated beams and columns, and really started off sort of the stock beam business, and then gradually as time went on moved more into projects and packages and starting combining steel and engineering and design along with the wood members itself. A couple of iconic, here we are in Penticton in 1962 where there's no railway there anymore, but we actually used to ship these beams by railway back then. The middle one there is the Korea Pavilion from Expo 67. It's one of only two buildings that are actually left from Expo 67. This one here. And of course the world's biggest hockey stick at Expo 86. And I'd add to this list of iconic structures that we've done the Olympic Oval in Richmond. So a little bit about glulam as we get going. You guys are familiar with the product. It's been around for a long time, 150 years now. Glue laminated beams have been in existence, and we make them big. We make them up to up to 6 feet deep and up to 100 feet long. These ones down here in the back up.
Red button. There.
Get my this one here. These are the biggest beams that Structureline ever made. They went into a recreation center in Canmore, Alberta. They're 110 feet long and 8 feet deep, and weighed 35,000 pounds apiece, if you can believe it. So that's a big piece of wood. And so moving on here, we've been involved in 3D modeling for almost 20 years now. So we were a real early adopter into this technology. We use a Swiss engineering product called CADWorks. So what we do is we get the architectural drawings and the structural drawings, and we put them in a 3D model. And that 3D model is the hub of everything that Structulam does. So from that 3D model, we create the shop drawings that go onto the floor for every member. We send the shop drawings out for the steel to be done by a steel fabricator. All of the parts lists and material lists come out of the model. Every nut, bolt, and screw is in there. And of course, we also produce the code for the CNC machine. So Structulam has invested heavily in technology. We have some of the biggest CNC machines in the world fabricating these wood members, and it's all driven from the CADWorks model. Here's a couple of things here. I'm trying not to overlap with what John's going to show. John's going to drill down a little bit further into what I'm doing. I think you got a couple of shots too, John?
I've got a couple of shots.
Of some of the machinery in that. But here's some, this is the gantry style CNC here, and it has a 110-foot bed, and it can fabricate down to about 1 or 2 millimeters in accuracy. Curves, arches, big members, and obviously it can shape, notch, drill, just about do anything in 5-axis. So there's really not much we can't make out of wood anymore thanks to a machine like that. We've had that one for about 10 years. Over here on the other side is a K2. That one's for the smaller members and straight pieces. Very fast machine though. And so I brought up the original slide there about glulam because although the product's been around a lot, we're doing more and more with it we never used to be able to do. And it's really a combination of that CNC machinery, the 3D modeling, and the advances in timber engineering. So you guys were at the UBC stairs building today, and you saw the stairs. Here they are there's one getting fabricated in our shop there. We use a lot of hidden connections. The trend is to hide the steel now. People don't want to see it exposed, so we spend a lot of time and effort hiding as much steel as possible. Stainless steel here. This is a custom one that's I'm going to show you this project later on. That's a prefabricated connector called a Sherpa, all hidden. And so there's been a real advancement in the connections. And so I just wanted to quickly go to a typical project that we work on. And here again, we get the structural drawings, and more often than not, they're in 2D. Some architects and engineers are sending us 3D models now, but it's still it's not common. Of course, you have a contractor here, general contractor or contract manager in the middle, and then of course you've got all the trades down here. So this is typically what we're doing. So we get, the drawings are coordinated here by the contractor, And, but over here you got Structulam using a 3D model. And what we happen quite often is we see anomalies, so it's requests for information going back to the architect, the engineer, through the contractor, not only us, but so is the steel guy and the concrete guy doing all this at the same time. And let me tell you, it's a slow process and fraught with error. And so, how do you coordinate when things are being changed left, right, and center here? Especially this one here, the wood and the steel, is a tough one to coordinate in this model. But it seems that most of our projects follow this way. A project that we did here, and Tom was a part of it when he worked for the Ellis Don on the Gala Ontario. There, they gave us the base model for the whole building. Gave everybody the base model, and then of course we had to use that and add in our wood members into that base model. So that was good. It was a good effort. The downside of what we had to do there was a Frank Gehry project. It was extremely complicated, and we had to use his software, which was called CATIA, and that made it quite expensive and time-consuming for us. The good news is it turned out very well. Here's the model for that. It's a block-long facade that goes all the way down Dundas Street in downtown Toronto. If you have seen this building, it's an amazing one. It's got no two pieces of wood were actually the same in the whole building because the geometry changes at every point. There it is going up, and that gives you an idea of our CNC machine framing for some of the connections that kept that thing together. So that was good. Here's a couple of shots of it when it was done, and it really is a spectacular one. This one we've been kicking around. I was talking to our guys in the detailing before I did this presentation today, and sometimes if we had that base model, and then it went down the line, first to the concrete guy, then to the steel guy, then to the wood guy, and we kept, using it, our stuff, adding material in, and then sending it on to the next person in the chain. I know that you'd have to go back when there's changes being made, but wow, that would be an improvement. And of course, if we got an issued for construction model right out of the gate, it would be awesome. It would be awesome. The problem, guys, is that we get a lot of drawings that are just mediocre at best, and really a lot of these buildings we work on, the design's not finished, frankly, when we get them, and we end up so it really slows down production. So anyway, some thoughts on that front. This is a project in Kelowna. I'm just going to show you the model quickly here. It's a 3-story apartment building. It's got glulam beams and columns, and then it has cross-lam. I'm going to show you this new product that we make and sell called cross-lam, 4 floors and ceiling. And this building, from the time we got the contract to the time we delivered it on site, was 3 months, just because it followed that perfect model, where the model was there, the drawings were excellent. We got a 3D model from the architect. We added our material in and got it on site, and it's just what's possible when things go well. Here it is in construction. Fantastic project. A couple of other ones I thought I'd throw in here and show you, and here's one that when the design's not done. This project was delayed in its process by over 2 years, just because we struggled with as the drawings weren't complete and when we got the contract. But this is the art gallery, Kimbell Art Museum in Dallas, Texas, and it is an iconic structure. These are the most expensive glulam beams ever made. They're almost perfect, and shipped all the way from Penticton to Dallas. But that project was delayed by, like I said, almost 2 years due to the drawings. Cross-lam by Structureline, I'll just tell you about this, and then I'm going to pass it over to John. If you're not familiar with this product, I'm sure you'll be seeing more of it as time goes on. If you went to UBC, you saw it it was one of the first ones we ever did. It was in the canopies of that UBC Earth Sciences building. Basically, we take the material, we put long lamellas down in a row, and then we put short ones at 90 degrees. Long, short, very much how you would build plywood, only we're not using veneers, we're using dimension lumber. And we can build them up to 3, 5, 7, 9 layers thick, and 40 feet long and up to 10 feet wide. And so if you can imagine, one of these things that's 40 feet long and 10 feet wide and 9 layers or 12 inches thick weighs about 10,000 pounds. So why do we do it? Because it replaces concrete. So if you think about it in the most basic terms, our glulam replaces steel and our cross-lam replaces concrete. There's some structural benefits that come along with it. Obviously, this is a big one. So here's a commercial building now, just like that one that I showed you there in Kelowna, completely prefabricated in our shop and then shipped to site. And then the assembly goes very quickly. As long as the structural steel or structural concrete is accurate, the building goes up quickly.
Really, that
Hey, John?
happens every time.
So we like to survey them first. For rapid assembly, there's some really cool things you can do because it acts like a concrete slab. You can span both directions, and so which allows you to do some cantilevering, and architects certainly like that. And of course, because everything is prefabricated in our factory down to incredibly small tolerances, there's really no waste on site. This is just a shot, and again, John's going to show you, this is the shot of the crossland production at Structureline. There's only two crossland plants in Canada, one in Penticton, ours, and another one in Quebec. So here's Fort McMurray Airport, just finished recently. There's the glulam beams, and that roof is all crossland panels. If you're through Fort McMurray, that's going to be a spectacular building. John, did you put this one on your slides?
I haven't. There are too many buildings to put on
Yeah.
a very short show.
There's an interesting use of crossland here. This one's this is a gym actually, and John erected it, we fabricated it, and it's in Kelowna. The idea here was, the money for the building was donated by the fellow that owns Kelowna Flightcraft, so the architect made it look like a wing, both inside and out. That was the look he was trying to get at, and I think it worked, eh?
Oh, it's a lovely building.
Elkford Community Center, again, a combination of glulam, crosslam, and the walls. Heli Ski Lodge. So this is because of that rapid assembly aspect that we can bring to the table with that prefabrication, is that if you're in an area where the building season's very short, this one went up and it had to go up in 2 months because that was the only time that there wasn't snow on the ground. And Ronald McDonald House here locally. I don't know if you've seen this one, guys, but it's here in Vancouver, Burnaby, all crosslam, top to bottom. And this is where the big future we see for cross-laminate buildings and for heavy timber buildings in general, and that's going taller and taller. So right now we're doing a 7-story, again, John erected. I think he's going to show you some slides of it in Prince George. Not?
Sorry.
Okay. He's not.
Next show.
It's this pretty cool building. It's just being finished now. So it'll be the tallest wood building in Western Canada. And we think, engineering-wise, we can go up to 30 stories. Practically, it looks like there's going to be 3 new projects in Canada here, and the tallest will be 14, 15 coming up. So the race is on for taller wood buildings, there's no doubt. So that's all I've got for you, and I'm going to pass it over to John. John and I, John's company and Structureline work together. We've liked that Fort McMurray job, like the Wood Innovation Center in Prince George, and the UBC building. And if he bitches about the fabricator, it's not us, okay? It's this guy.
Okay. All right, got the controls. I'm going to be a little bit rushed for time here. We're going to zip through it fairly quickly. So they warned me never start off a presentation with a graph. Start off with a joke or a story or something shocking. But this graph actually is all of those. It's both a joke, it's a story, and it is shocking. This is construction labor productivity it's US statistics, 1964 and 2012. This is non-farm industry, 2.5 times increase. This is construction productivity. In 1964, the laborer on site was producing more square footage of whatever it was he's doing than the worker is today. And that tells a story. It's a sad story, but I think with what we're talking about here, BIM and off-site construction, we have a possibility of starting pushing that up, and pushing that up pretty dramatically. So it's about building better buildings, faster, at lower cost, and with some profit. You know what? Because it's a pretty important part of why all of us are here. I know we love to do what we do, but we also like to make a bit of money at it. So I come out of the log building industry, and in 1989, 90% of my business was shipped to Japan, 10% of it or 8% of it to Europe. So we've been containerizing and panelizing and shipping stuff around the world for a long time. So off-site construction is a bit of a natural for us. Hang on, I'm just going to go back on that one. Quite a complex job, modeled in ArchiCAD, fabricated off-site with very little pre-fitting. So timber framers and log builders have actually been doing this for a long time. That particular project had 365 pieces modeled in ArchiCAD, cut by hand. Haven't found a CNC machine that can do that yet, though Hundegger is working on it. The problem we found with ArchiCAD was great architectural tool, good coordinating tool, great for visualizing, but for going to manufacturing, didn't do it for us. And I used to own it and bought something called Dietrich's, which is very similar to the CADWorks. So now you add 3D modeling, good communication, good team, and a CNC machine. This is a timber frame project we did with Daizen. And some interesting things happened when we added CNC manufacturing into that. We all of a sudden started to have some very predictable events, including my favorite prediction is what's my profit margin going to look like at the end of it. But we had very high quality expectations. The steel in this, I mean, that's the brand for the ranch. These are tiny little wedges holding these pieces together. We fortunately had a great steel fabricator, Adam Integrated, who does 3D models everything. This is actually a template. For about 25 bucks, he'll cut me a template that I'll give to the GC to lay out his bolt positions. It's got axis line, center point. The axis lines can be wherever your grid line is, and I'll ship that to site, and you know, I'll have it stamped for which locations it's located at. Because the big challenge with these jobs is not in the material. When I look at a building, I look at a building as made up of connections. And it's not the beam I'm interested in, it's what happens at the end of the beam when it connects to a column, what happens to the column when it connects to the concrete, to the steel. It's at the connections that all of the issues occur. And it's the connections, not just physical, but it's the connections between you and I and the contractor and the contract. So it's all about connections, but that's a slightly different topic. This is actually one of the first jobs that I did with Structulam. I haven't, this is a finished building and there's a whole bunch of log in it, and it's the log that makes it look nice. The glulam, it holds it up, but it's the log that puts it over the top. But this was an interesting job in that we bid it in the typical design, bid, build. In fact, the concrete was already in when we bid our portion of the work. And I could see there was a 3D model because there was a nice pretty picture on the cover of the plans, and I asked the architect, can I have the 3D model, because this is a fairly complex round structure with little pockets that each of these have to fit in with a fair bit of tolerance. And they said, well, we don't really have a 3D model. I said, well, how'd you get that picture? Well, we did sort of 3D model it in SketchUp. And SketchUp is not 3D modeling, it's 3D wanking. It just is not the same thing. It's a lovely visualizing tool, but when architects come to us and go, yes, we've 3D modeled it, and they send me a little SketchUp file, oh my Lord. So we did a 3D model based on the drawings to the best of our ability to discover where this concrete was. Came to site with my laptop, laser pointer, and discovered that these were they were out of position by up to 50 millimeters. This connection here, while a clever connection, really only had tolerance for 20 millimeters. We brought in a surveyor with a total station, mapped each corner of those pockets, turned around to Structulam, gave them a data file. They just tweaked every piece. Now, unfortunately, instead of these all being repeats around, now all of a sudden every piece was unique, but the CNC machine doesn't really care. As long as you can capture that information in the model, the CNC machine cuts it just as fast at 22.5 degrees as it does at 22.9 degrees. If we hadn't done that, I'd still be on site trying to make it fit. It's actually a lovely structure. So state-of-the-art CNC manufacturing, Bill's talked about that a little bit, but that all of a sudden opens up some possibilities of what you can do and what's possible and what's predictable. Trying to keep it predictable, again, it's at the connections. Occasionally, you know, the CNC machine can't do it, and that the largest, sometimes you've got to have guys that can cut stuff by hand, and so you still need good people. But using CNC machine is about leveraging good people by giving them, some exceptional tools and ability to create stuff that by hand, that's pretty labor intensive. This was actually a small little CNC cross-laminated timber project we did before the CNC machine was online. The press was working, so we cut it by hand. It was a unique design. The owner, GC, and main labor crew was the architect. It's out in the middle of nowhere off the power grid, just south of the border in Washington. So he had a tight budget. It was a structure that would have been impossible to build stick frame. It would not have worked stick frame. The engineer was a really creative engineer, Bernard Gaffner. He was also on the assembly crew. So the assembly crew was me, the engineer, and the architect. Talk about stress. Actually, it was a hoot. And it went together, really well. You can see it's just a folded 3-ply CLT box. This corner right here actually has no support under it. I put a temporary support in there, but Bernard assured me, no, I've got it worked out. It's this fold in the roof that carries this load. It's some engineered, fully threaded screws. Very simple building. Went together very quickly. This was Jesse Garlick was the architect, and this was his reasons for using CLT in the design. He wanted a precise crafted building. He had a real issue with logistics and available labor. He wanted to go up quickly. He had basically a summer to build the building. So there were 4 people to put it together and 2 people to finish the building. We modeled the whole thing to the point of we even modeled the wood fiber insulation because we were ordering that from Germany. I didn't want to order too much, too little, so the model in the Dietrichs, and I have to admit he used SketchUp to do his concept. So it was useful, but it wasn't for production. Yeah, so interesting, fun building. Oh, you know what? I went a little too fast on that. Was Bernard's comments on why he liked it. I'm going to skip on that because I am running out of time. That was actually my holiday that year. I do strange holidays. My wife is getting a little tired. Our last holiday was go down to Belize, get in a small boat, go 50 miles offshore, out past the Blue Hole to Lighthouse Reef, pull out chainsaw and build a building. And then sweep the sawdust out before the guests arrived. But that's my idea of a holiday. This was actually probably one of the first commercial CLTs off your press. This is Earth Science Building, UBC. It was an interesting job. I got a call from Bill Downing. They wanted me to go down and do some consulting. They'd had a crane accident on site. It dropped a column, and I was going to sort of go look at the process. There was basically a standard condo framing crew trying to put this thing together using the famous temp labor from Vancouver. Call your labor temp agency up and hope the guy shows up sober. They were struggling. It wasn't entirely their fault. A lot of it was an interesting project. I went down and did consulting and concluded that lifting heavy pieces is the smallest of their problems. And Bill cornered me in a restaurant booth and promised me helicopter rides and a crane at the end of the job if I would take it on, and we did. And actually we had a hoot. Bird was just fabulous to work with, the engineer and architect. Once they got used to my style, which is, I need to know how it works. I need to know the rationale behind it before I do it. But so that was, we sort of felt like Knights to the rescue. That was the good. I do an earlier version of this talk, which I called Tales of Blood-Chilling Horror from the Job Site. That was my pre-Halloween title. So I sort of did the good, the bad, and the ugly on several different projects. I've deleted a few of those, but yeah, they had a great team of people that were really focused on producing a product that was exceptional. And those of you who were on the tour this morning saw, I got 20 minutes. I'm actually probably rushing this. I think they saw the results. I think it could have worked a lot better. There's the first CLT flying up to the roof. Now the building itself, most of the floors did not have CLT on it. They had LSL because the CLT press wasn't ready. If the press had been ready, 3 or 4 months earlier, you would have seen a lot more CLT in that building. So that was the first panel. The not so good. So we had some issues, and one of the big issues to my mind with offsite construction and prefabrication is we actually need to change the way we contract buildings. Design, bid, build sucks. I don't even go on BC bid anymore because it's a waste of my time. There are projects that I'm not suited to that are not going to go well because the nature of communication, the connections are already disconnected before you even start the process. So for instance, weather exposure, shipping stuff to site. Well, Structureline doesn't get paid until material arrives on site, but for an efficient process, you want to have it prefabricated and stored somewhere other than a tight little site at UBC. Low bid gets the job. I won't even go there. Actually, the Swiss have a great system on public bidding. The second to low bid gets the job. They throw the low bid out. Just think of the impact of that on how people bid, because the low bid is often the guy who's desperate for a job. He's going bankrupt and needs some cash flow, and maybe this job will save him. Ain't gonna happen. Crane and crane planning. There was very little. The crane planning, basically, the crane was supplied by the forming contractor, and nobody looked at what the crane was going to be used for and how what kind of crane cycle times were going to be required. So again, there's the first panel being landed. Up until then, we'd struggled with crane access, and we had a clear site. We've got the panels lined up. The crane is ours. We are going to kick ass. We're going to put a panel up every 18 minutes. It's 8 foot wide by 36 foot long. We're going to cover real estate like nobody's business. And that's the first panel, and we're now waiting for the second panel. And all of a sudden, I've got a camera up on the roof taking pictures every minute, and it captures a piece of plumbing flying by going the other way, and my guys are sort of still waiting there, and now it captures, actually that's an outhouse with 40 foot of toilet paper hanging out of it going the other way. My crew has completely disappeared at this point. I think they've gone for early lunch, and wait for it, 50 minutes later, there's the next panel. So if you're going to do production, you can't just have great manufacturing, you just can't, great plans, you've got to have a connection through the whole process. And so nobody bothered to look at the crane chart. I foam at the mouth about crane planning. I had to bring this crane in every 7 days. And what did that sucker cost per day to bring him in? About $4,500 to lift this guy, because this crane here couldn't actually lift this guy. That was one of the first things when I came on site is, could I have the crane charts, please? And the crane planning. So crane planning and how you're going to lift this stuff, how you're going to get it into position is a huge one. Concrete. Right here, you can't really see this, but there's a big, huge hole blasted in the side of the concrete because this connection is a epoxied doweled connection that's got to fit into this corner for this column to attach to. But there's some 1.25 inch rebar just completely filling that corner, making it impossible to make that connection. There was a disconnect there, a lack of communication. Tolerances, I just love to, one more thing for me to foam at the mouth about. This is CSA, this is a chart pulled from CSA A23.1, which is acceptable tolerances, alignment of concrete members. And at 19.2 meters or greater, my plus minus is 50 millimeters. Anybody, I mean, if I'd asked you to guess what's acceptable tolerances on the Canadian Standards Association standard, would you even guess closer to that? I'm bringing a product to site that's cut to a couple of millimeters, and I've got to connect to that. So you've got to manage tolerances. I really like to see language on both in documents and on contracts about what tolerances are necessary for this particular project. Because if you don't specify a tolerance, this is your tolerance. You know, if you go to court and complain, and he'll go, you know what, I was 49 mils out. I was good to go. And the judge is going to agree with him. So, and unfortunately, too much construction is adversarial. Too many construction projects are managed by lawyers. I hate to say it. Tolerating tolerances, you know, we'll go through a plan and mark it up and go, you know, what are our critical dimensions? We've got tolerances here. If this is out slightly, you know, we'll mark up things that we'd like to see changed. It's usually worth paying attention to that, because on site this elevator core was 80 mils out of position with a 90-foot beam attached to it that was 80 mils short all of a sudden. Slowed us down a little bit. I'm not mentioning any names to protect the innocent and the guilty. Lost effectiveness due to break of scope. So on the job we just saw there was a concrete building and there was a wood building. And the concrete building was built to that previous tolerance. No, actually it was quite a bit better than that, I should say. But there's a connection between the buildings because of the different period of the building, because they move differently during a seismic event. There needed to be a movement joint that could carry load. And it was quite a complex movement joint. One half of it was manufactured in Structulam subcontractor, which was Atom Integrated on that job. And that was within a couple of mils. The other half was by the steel concrete guys, and he was actually working in inches. And his tolerance was, they just didn't go together. The cost to fix that was huge. Some of you were wondering how those stairs were connected. This is a piece of steel in the shape of a 7 that matches one here that's been epoxied in the shop with holes pre-drilled for chases. This wasn't even close. Fortunately, we had enough lead time that we took this piece of steel, sent it back to this fabricator, had him refabricated so it matched his 3D model, because this steel fabricator 3D models everything. This one just goes for it. Context and connection. How many of you remember this lovely corner when in the building? It's a beautiful corner right here. Did you see the inside of that wall when we walked into the lovely the lecture theater? That was the inside face of that wall. And that has, I don't know what that piece of beautiful stainless steel cost, well, it's right there. And in a 3D modeling process, you wouldn't have made that out of stainless steel. You would have made that out of ordinary steel. You wouldn't have had me rework it for a whole bunch of reasons. You wouldn't have round lathed the columns that are in there. You would have saved yourself probably about 40 grand by taking a look and understanding that the context was, this will never be seen. It just needs to do the job structurally. I don't care what it looks like. 3D in context. Bill talked about connectors. What really makes a lot of these buildings possible is some of the engineered connectors that are available, Sherpa, Pitzel, Knapp. You need very high tolerance. If you don't get this just right, the tolerance on that is a couple of millimeters. If you're out of position by more than that, it doesn't go together very well. If it does go together, it drops together and you've got huge capacity. Epoxy is interesting what you can do with epoxy. This is the stair. We're just lowering the stair landing, which arrived from Structureland's shop with all of this mesh pre-installed. We had to position the stairs in the correct position to engage that, bring it all together, seal it, and then pump it full of epoxy. I ended up writing a report on these stairs called What I Learned at UBC, and that's a continuing story. Engineered screws. A lot of these connections, I mean, this is a monster big connections, column and a beam. It's a lap joint with 6 screws in it. I would have, 10 years ago, I would have expected 800, $1,000 worth of steel in there, pins all over the place. Now, you need a big, beefy guy to drive. In fact, you need 2 guys to drive it. One is driving it because it's a 1 meter long screw. So the one guy is actually lowering the genie as the screw goes in and then assisting. So you need to understand how to drive these screws. That's our magic ingredient, a product called Screw Grab, but I'm not even supposed to show that. It gives me a competitive advantage. Oh, my favorite on plans is by others. I actually search for that by others thing, because you know, you've got to, and again, it's break in scope, and what happens then, the by others brothers, they're going to show up on site and rescue the day. I've actually thought of actually registering the name, the by others brothers, because we seem to do a lot of that, but nobody ever pays those invoices. So pick your people carefully is really important. This was a couple of summers ago. This is actually the connection. Bill showed you the UBC Fitness Center in Kelowna, and it's using mesh and epoxy pulled together, but that job was supposed to start 6 weeks before another job I was doing up in Fort McMurray Airport. They both started on the same day, so my A team was up in Fort McMurray, and me and my B team. I borrowed this fellow from the contractor, Pete, the 60-year-old ex-male stripper. And you know what? Great attitude, this guy. This guy turned out to be a super hand. You know, and it's attitude, bring attitude with you, skill I can teach. He was a genius on this machine. He could thread himself in between there. I couldn't get him to quit smoking all day, so pick your people carefully, pick your subcontractors carefully. Make sure they've got good people, make sure they know what they're doing. Yeah, he was a lot of fun. Material handling is really critical. Keep it clean. We'll put down, this was a particularly muddy job site. We had filter fabric. I shipped a whole bunch of sawdust from our site, a boot cleaning brush. Actually, that really helps, having smart guys that don't walk all over your panels. That's pretty critical on how you handle the material. Organizing it so it comes off the truck and it's sitting in the order you're going to need it is really critical, and that requires a great deal of pre-planning. Lessons learned. This was actually a lesson we learned on the Fort Mac Airport. That's the one with the elevator core 80 mils out of position. We arrived on site and surveyed with our little Hilti lasers and whatnot, and pretty quickly determined stuff wasn't where we thought it was, but nobody believed us. And so I ended up, Leica makes a series of total station that are designed for builders. So I don't have to actually go back to school to learn how to use it. And it actually hooks directly into the Dietrich software. So I can, if I need to, I can query my model on site and very accurately discover where I am. We looked at doing laser scanner, but actually we found this was a more useful tool than the laser scanner. Laser scanner produces too much data. This produces just the data you need. So you can go and do an as-built. I can set that machine up and scan, and shoot all the critical data points on the Ramada Hotel and have it come directly into the Dietrichs. If I actually set some parameters, I can click on 3 points and Dietrichs will put a wall in for me, right, defined by those 3 points. So that one's been a huge help. A total station, the nice thing about a total station, it tends to intimidate contractors a little bit. It's not like your little spinning laser. The spinning laser doesn't. You pull that one out, and then there's a little added module that prints out change orders. So I haven't bought that one yet. They want a huge amount of money for it, but so I'm getting actually fairly close to the end of the job. Don't neglect the details. I'm too often on projects. I'm doing the heavy timber install, but I ask them, what's the finish? What kind of finish you're putting on the building? And I haven't seen Thompson's water seal, but pretty damn close. Decisions made. This is the Fort Mac Airport. Anybody here from the firm that designed that? Oh, good. So I can slag it. It's a big square box. Without the wood in this building, this would just be one more Fort Mac big square but ugly box. The wood, once it was properly finished, we ended up going back in and taking over the finishing, which we've done on several projects. And the transformative effect of well-finished wood in that space is quite impressive. It's actually a stunning space. But if this were concrete or steel or whatnot, just wouldn't cut it. It would be another Fort Mac thing. I don't know if anybody's flown into their present airport, but this is going to be a welcome change from that jammed, crowded little lobby there. Software, there's a few softwares available for the wood manufacturing industry. HSB CAD. Advantage of it is it sits on Autodesk, so it probably does the best job of communicating with North American software. The disadvantage of it is it sits on Autodesk. Sorry, I'm not a huge AutoCAD fan because I never could learn to run the damn stuff. But then there's CADWorks, which is a Swiss product, and they're more into curvy stuff. And if they're doing a lot of curved, freeform stuff, CADWorks great. There's some stuff I like about it. My favorite is Dietrich's, except their logo sort of sucks, so I changed the logo a little bit. I thought, I needed to add something curvy in there. I know it's Dietrich's, but it's a different Dietrich's. All of them are pretty critical tools for that off-site manufacturing. So the first thing your model does is it generates, this pretty image, and you can do that in almost any. I mean, SketchUp does a great job of that. But the difference with these softwares is they drill down to the details. They put in every screw. Every one of those screws actually has parametric information that can go into ordering, that actually you can attach stress values to it for engineering. The Dietrich's, this is actual screws in the model. There's a small hole drilled in every position in the CNC machine. This is a lifting point here, another lifting point here. There's that on site. There's a lifting point, there's a lifting point. Every screw, you've got a position for it, the angle's being preset. And when you order your material, you get exactly what you need. And if you organize it properly, it's where you need it, when you need it, at the right price. Some of the softwares, the Dietrich's has an engineering module that allows you to analyze connections or beams. It also can analyze thermal performance in wall assemblies, dew point things. It does some pretty cool stuff. All of the softwares have got some pretty interesting capabilities. The key thing with all of them is they talk to the big machines. They talk to the CNC machines, and that's critical for this off-site manufacturing. Oh, okay. So actually, that was a job we did just last fall in Taiwan, of all things. It was engineered in Vancouver with Equilibrium, made in Austria and shipped to Taiwan. And we went over and coordinated putting the building together, and went fairly well. But I was actually disappointed in the drawings. We ended up getting their model and bringing it into Dietrich's and doing our own assembly drawings. So actually, your drawings are better. And these are the guys that invented CLT. So you've got to understand. You've got to be careful what you're asking for. You've got to define your specifications really, really carefully, and make sure you're getting what you expect. Where to now? Actually, this is just some pictures I found. A student project in Stuttgart, I believe, playing with some computational organic construction, CNCing stuff. I don't think any of them have any construction experience, and yet they built that structure with a little robot in actually pretty short time frame. It's a temporary structure design. The design of it is actually based on sand dollar. If you've ever looked at a sand dollar's got tiny interlocking fingers at the plates, and they looked at that as a structural system and built these modules. Using a combination of what we were talking about earlier, computational and organic, but they fabricated it off-site with labor that actually was very unskilled, enthusiastic, and cheap students. I know I get a practicum student from the University of Rosenheim that comes and works with us every year. The nice thing about engineering program there is it's very difficult to get into either their engineering or architecture program without a trade ticket. So I actually get a third-year engineering student who actually knows which end of a hammer is for what, and I can usually have them go out and fire up a chainsaw and do some work. So that's that. Any questions? Or you know what? I've got 12 seconds left. I think we cut her pretty fine. So there we go.